Hey, welcome back, everybody. And as you can probably hear, there is some networking going on at this event here. And remember, you can go in and go into the app and you can network with people virtually, and you can connect with them and mingle and do all those sort of business introductions that you might want to do. But anyway, on with the next session. And joining me now, I'm delighted to say, we have Nick Giannakakis. He's the Group Chief Information Officer at Motorola, based in London. And he is going to talk to us today about the use of AI in large-scale energy complexes. Nick was born, as you might have guessed from his name, in the western part of Greece. He holds a degree in physics, a Master of Science in Industrial Systems Management and Administration, and is a graduate of the International Institute for Management Development in Lausanne. He has 15 years of international experience in positions including Director and General Manager of Informatics in distinguished multinational clubs. He was also named one of the top 100 Chief Information Officers for 2019. Now, Nick is eager to use technology to drive digital transformation, which he believes has brought tremendous cost savings and process improvement to companies around the world. And I'm sure he'll be telling us more about that in a minute. He's worked as CTO for globally distinguished brands such as British American Tobacco, Coca-Cola, and Richemont. So welcome, Nick. Welcome to the show.
Nice to see you, Scott, and happy to be with you, along with you.
Excellent. Okay, Nick, well, I'll hand over to you for your presentation.
Thank you. Today, I would like to share with you our use case, our success story, I would say, in that has to do with predictive maintenance solution for our refinery. First and foremost, please allow me to share some details, some info for our Motorola Group. Motorola is a company, is a conglomerate based in south part of Europe, consists of more than 2,900 employees, a revenue of approximately 10 billion euros. And the important aspect is that we are an export company. We're exporting in more than 45 countries around the globe. And we have three main distinct pillars. Refinery, a complex manufacturing, which will be our case today, but also a very large footprint in retail with more than 1,400 gas stations. And last but not least, utilities. We are using brands like Shell in south part of Europe, and of course we have, I would say, quite a large market share, more than 27% in the companies in the countries that we operate. Today, we will focus in our refinery. Refinery is the backbone of our overall organization. Is a very complex manufacturing estate with more than 85,000 barrels per day. I would say a complex plant with more than 2,600,000 cubic meters storage capacity. And to understand what we're talking about here, we have more than 3,000 vessels berthed at our port facilities on an annual basis. More than 220 trucks are served on a daily basis from our truck loading terminal. So we're discussing about a very heavy manufacturing complex. What was our challenge? The challenge is for our organization is to, although we have standard maintenance practices in place, we want to have a more accurate way to predict and address equipment problems before they occur. We have deployed sensors constantly and collecting data across the entire production line, but we want to ensure that we're making the most of information in order for us to better understand and mainly forecast abnormal events before they occur. Last but not least, we want this specific information to be shared with the relevant departments in order to be able to address it I would say, on a timely manner. Having said that, the definition of our problem: monitor process critical compressors, analyze historical data, forecast the machine session behavior, and last but not least, predict the sensor and trip threshold exceedance. If we do that successfully, we need to send the early notifications about upcoming abnormal events and avoid unexpected shutdowns to the respective team. The mechanism to do that is through root cause analysis and real-time system health monitoring, and of course, sensor-level time series forecasting on a 24-hour basis. Just to give you an idea of the equipments that we are monitoring here, we are discussing about compressors with more than 8 rotating equipments and more than 10 sensors per equipment. So, to make a long story short, a very complicated, I would say, compressor, a very complicated manufacturing item in order to be able to monitor. Our solution, we have two main data sources, the sensor operational data and trip and alarm threshold. We have a process for data ingestion, and we have at the middle of our solution the abnormal behavior prediction module. Last but not least, at the end of it, we have the prediction dashboard and the email alert notification. This is our overall, I would say, business architecture overview of the solution of the AI and ML solution that we have put in place. What are those data sources? Everyone understands we're discussing about sensor data like engineer tags, historical data and ratings, upper and lower normal limits. They are used for data understanding, data quality assessments, and so forth. We do blend those sensor data with operational calendar ones to have log of historical failures with timestamp, positioning, and so forth. Schedule shutdowns, why? Because exactly those periods needs to be excluded from our overall analysis, along with our maintenance calendar. We need also to tag on special events in order to be able to understand the relevant behavior. Time series and data cleansing are essential in order to keeping only in scope the relevant operation conditions, and of course to be able to understand the special cases. System architecture. We want to have breakdown of systems to subsystems and the relevant components in order for us to understand and work on the system attributes and correlations. The heart of what we're doing here in AI and ML is the abnormal behavior prediction module. We want to learn from what is normal. We want to monitor the behavior, flag what is abnormal, and of course, predict potential failures. This is the sequence, and this is the repetitive sequence, the feedback of the overall process, what we're doing. It consists of historical data, corresponds to healthy conditions, the prediction of future and performance level, progressive error calculation, near real-time and identify abnormal behavior, and of course, prediction and degradation path of various parts of our system. The abnormal behavior prediction module for us is the heart of what we're doing. That's why I want to see that we have three distinct parts. The sensor level with the nearline data, the forecast values, the measured values, and detect of anomaly. So we're discussing anomalies, trips, and failures. The part level, fault matrix, determined affected area, and the system level with the system degradation. All of it consists of what we call the abnormal behavior prediction module, the heart of what we do have in place. From the time that we will be able to run this successfully, we do have a dashboard, because at the end of the day, this will be the system, the screen that our people in the relevant departments will be able to monitor, and they will have predictive scores that indicate upcoming fixed failures, but also forecast abnormal behavior. Last but not least, we will provide them with email alert notification mechanism for them to be able to track exactly, to have an automatic alert mechanism that will focus on select users, the users that work in specific shifts, in order to have this push-style notification. In all this way, we would like to ensure that we have timely awareness and we have the relevant shifts, being able to consume the alarming situation insights. This project took us, I would say, it took specific steps in order for us to go from proof of concept to pilot and then to scale it up. You see here the relevant timeline. It is a process that started, the proof of concept started and I would say lasted for 3.5 weeks. The technology that we have used around that was based on our core SAP technology with business understanding, with data preparation, modeling, evaluation, and deployment. The scale-up process we are now in the scale-up process, and we hope to be able to accomplish that by mid-year 2022. We have identified that running the lesson learned around that was simply having a proof of concept is the starting point. But pilot and then the scale-up process are the most essential one. I would like to mention here that the outcomes of overall proof of concept. We were able to introduce this approach and to have the endorsement for our executive committee with a very positive outcomes through our proof of concept. More than 80% accuracy in prediction of trip threshold exceedance events and more than 99% accuracy in prediction of the relevant exceedance. Those numbers speak by themselves. If we try to see now the solution architecture, you will see that we have in the data science and ML environment the relevant HANA database, and on top of this database we have the relevant Python-based ML training. We are using the SAP solution for Analytics Cloud as our dashboard for review the relevant results. In regards to data ingestion, this gateway, this DMZ, are most complicated, and this is our next focus, how we will be able to automate that up to the last scale. I would like to share what we have done and what was the actual outcomes around that. We have the solution has two main pillars, the root cause analysis and the time series forecasting. The root cause analysis define normal values for each tagging, learning from periods of normal operation. I'm repeating, normal operation, not shutdowns or abnormal operation. We compare tag behaviors 1 week before actual events to what is normal, and we were able, through this root cause analysis, simply discover abnormal behavior. And with the time series forecast, we went one step beyond that. We were able to measure mean absolute percentage errors. That means we were able to do a forecast based on time series model for each specific tag for behavior which is abnormal. So we're using the root cause analysis and the time series forecast. What was the outcome? On the left side, you will see the compressions with their technical names. We are using that because at the end of the day, those are the equipment that we are using, and you will see that our success story around that. You will see that events explained and predicted, we went from 77 up to 100%. And the response time, what is that? This is the response time for abnormal events, the lag time that we are giving to people that are in shift for them to be able to react from 20 hours up to 120 hours. Simply meaning, with the use of the root cause analysis, we are able to give a time window for our people in the relevant shifts, more than 20 hours for them to react for an upcoming abnormal event. Which events explained and predictive? You consider relevant percentage. Again, up to 60% we consider as a success story. We are here above 60%, and we reached also the level of 70% in the time series forecast. That simply means that we supplied our people in the shifts with the relevant prediction model that allows them to be able to react on a timely manner for abnormal events as predicted by our system. What we gave to them, what they do have in front of them, each shift has in front of them a dashboard like that, where it has what we call the 360 view of all the equipments in front of them. You will see on the vertical space all the equipments. You will see that they have last the next 24 hours. What that means, the system, this dashboard, gives to them what is going to happen according to the system for the next 24 hours, split by tags and sensors. They have the view of what we call normal operations, what actual and predicted trip instances, and of course, the actual and predicted alarm instances. We are able to show to them what is considered as abnormal behavior, and of course, a hyperlink to the details. So with a simple dashboard, every shift has the relevant prediction at their fingertips. These are split and going even into more detail by machine screen, group by tag types, so they're able to, to deep dive and analyze, group by criticality, analyze the relevant prediction and abnormal behavior up at machine level. And of course, if they want to go to in details, they can go to actual value, what happened the last 24 hours, what is predicted in the next 24 hours, and the relevant details. Last but not least, the shift supervisor is able to see the analysis outcomes, what email notifications has been sent to her team, and of course, to be able to filter and combine the relevant information. In this way, we have supplied a shift with the relevant tools to be able to predict the relevant abnormal events. I would like here to focus on the results and benefits of this solution for our organization. Yes, we were able to have continuous health monitoring to have the relevant prediction. This interpreted to us to cost savings. Why? Because if you see the relevant refinery, all the refineries, one of, I would say, the main areas that always recommended from every bibliography as potential use case for machine learning is the maintenance. Why? Because hundreds of millions are spent on an annual basis in refineries as maintenance OPEX. So this solution, first and foremost, attacks this maintenance OPEX spent on an annual basis. Safety. Severe events are prevented and effectively address the relevant identified risks. We're discussing about a very complex plant where the relevant risks has to do with hazard materials and so forth. We allow our shifts, we allow our maintenance department to have more effective planning and have even value insights and domain knowledge. How have we done that? I would like to focus on two specific KPIs. More than 70% accuracy. Abnormal events are able to be predicted between 20 and 120 hours in advance using root cause analysis and historical data. So we are giving a tool and equipment to our shifts that allow us to have, I would say, accurate prediction with more than 77% accuracy, 20 hours at least before it happens. This, for us, is very, very, I would say, a success story that has been published internally, has been considered as such also from our partners. SAP has been already published to the relevant as a reference to the SAP world and, of course, to our peer community. For me, this is the first and one of the most successful attempts for us towards our digital refinery and towards our AI experimentation. I'm at your disposal for any questions that you may have.
Okay, thank you, Nick. I mean, that was great. There was a lot of detail there, obviously, that you went into. I do have some questions for you, and I see that we've had a few questions come in while you were talking there as well. But I just had a general question to begin with, because towards the beginning there, you said that Motorola is an exporting company. can I just ask you, as an exporting company, how has the disruption to the global supply chain impacted your business?
You mean from the COVID situation or in general?
In general, I mean, the COVID situation, obviously, for anyone in the UK, we also have a fallout from Brexit and the implications of that as well. Obviously, global disruption to supply chains is impacting everybody at the moment. I just wondered how it's impacting you.
Yes, and I have to say that the past year, 2020, was a very difficult year. And our supply chain has been seriously disrupted by two main factors: the global situation, as we all know, but also we had, in our specific industry, we had, I would say, also a relevant phenomenon that needed to be addressed with the drop price of oil and shortage of supply and several other events. How we reacted to that, because I think this is one of the most important aspects. I would like to say with effective planning. We have established and we try to run a lot of what-if scenarios at the start of, I would say, the pandemic situation. And this was a key aspect that allowed us to react successfully in the overall situation. I would like to mention here that our overall inventory there are several billions in our overall inventory, and not be able to react effectively on this one consists of a very serious hit in our balance sheet. Our results in 2020 show that we had a very, very good reaction on this one.
And I assume that a lot of that reaction and that planning was you benefited from the implementation of technology there.
Absolutely. Give you a very simple example. We were able to put in place in a very short time frame a corporate planning system which allow us to run multiple what-if scenarios. And based on those, we were able to react accordingly. That was something that the technology department, our digital department, working along with the strategy and planning department, were able to put in place in a time frame of 2.5 months.
Okay. And now I think it's fair to say that certain industries and heavy industries they've been a bit slow, maybe in the adoption of digital and in their digital transformations. Would you say that heavy industries are slow to see the potential benefits of technology like AI?
Please allow me to say that, yes, there is this perception, and it has, I would say, some true elements on it. But what we have seen at the past 2 years, we have seen a very huge push from a very huge leap from the heavy industry towards the adoption of technology. Concept as the digital worker, concept as effective planning I could put around here, machine learning in predictive maintenance are concepts that has been, let's say, developed, and they are success stories from the heavy industry. If you see, I can note, I would say also very big success stories from our peer companies. Equinor is one of those for us as a North Star. So what I'm saying is, it is true that we didn't start with the right pace, but also with the help of the COVID, we have been accelerated very seriously. And last but not least, don't forget that for us, it's the adoption of technology is essential. It is part of our existence journey now.
Yeah, no, absolutely. And you showed us some really impressive figures there in terms of the benefits that you've seen and the predictability and everything else. Do you have a figure on what cost savings you might have achieved as a result of this?
Definitely I have. It has been shared also with my executive committee, but we don't want to publish it now. We are quite cautious around that. We want this to be reflected first in our P&L and balance sheet, and then to be able to publish it at a wider audience.
Okay, I understand that, but I assume you're very happy with the savings you've achieved.
I can assure you that this is not only my view, this is the whole management view, that this has been considered as one of the most successful technology initiatives of 2020 and 2021.
Okay, great. And I assume that one of the benefits of this is obviously you will announce the amazing results that you've achieved, and I assume other companies are going to be then adopting this same technology as well.
Absolutely, and I have to say that we follow here the example of other peer organizations that they were a little bit more advanced than ourselves. What is the challenge now? Because this is also an important aspect. What's next? Because from the time that you are bringing this into the organization, you open the appetite. And for me, as a Chief Information Officer, I'm continuously looking what is next for our AI. I'm telling you now that we are experimenting now with the use of artificial intelligence in our trading business, in order to be able to predict, prices of our natural gas, to be able to predict, our trading aspects on that. And this is the new frontier that I'm currently focused upon.
Wow. Okay. Well, make sure you share that information with me, won't you, Nick? Because you'll make me a rich man, so I'd appreciate that. Okay, that's all we've got time for right now. So if you do have any more questions for Nick, you can reach out to him directly through the event app here, and I'm sure he'll be delighted to answer any questions, apart from how much money he's managed to save motor oil, of course, by adopting the AI. But for now, thank you very much, Nick, and yeah, we'll see you again soon.
Thank you very much, Scott. Take care.
Okay, so another great session there from Nick Giannakakis, and stay tuned. We'll be back with you in a couple of minutes for the next session. But first, we've got a few messages for you.